Hello, this is a final presentation for our group project called Medication Cost Application. Our team members' names are Tianyang, Alipan, Stephanie, and Dianzu. My name is Dianzu. I want to introduce our group project. The project's goal is to develop a web application which provider can use to prescribe medication with low cost to patients. The web application contains a list of patients that provider can access, and it also contains a list of proper medications that provider can choose to prescribe for each patient. For the project's background and needs, in the United States, the prescription drug prices are very high right now. The patients always face financial aid distress and they cannot afford drugs high cost. So there's a need to find a solution which can help patients prescribe medication with low cost that they can afford based on their income. For the project solution, our medication cost applications address a need by delivering proper medication costs to patients based on their income. Within the application, a provider can choose among a selection of medications to prescribe which drug the patients will be able to afford. When the provider prescribes the medication request will be set. It also can be checked within the applications. This is also a chat feature which provider can use to send message to remind patients that their prescriptions are not getting filled. It can help provider can have a conversation with patients for their unfilled prescription.
Hi, I'm Tianyang Gao, and now I'm introducing the research retrospective part. Throughout this project, we conducted both academic and technical research to ensure its relevance and feasibility. On the academic side, we reviewed reports from U.S. Department of Health and Human Services, as well as multiple peer-reviewed articles to document that U.S. drug prices are rising by about 6% annually and sit nearly 300% above other OECD countries. As a result, providers may unknowingly prescribe medications that their patients cannot afford, leading to skipped doses, therapy discontinuation, and suboptimal treatment choices. Patients often face financial distress, delay refills, or abandon treatment entirely. This analysis highlights the urgent need for a tool that provides patient-specific medication costs in real time at the point of prescribing. And that's why we finally decided to do this medication cost application. And on the technical side, we initially attempted to integrate real pricing data through GoldRx or Needy Math APIs, but encountered access restrictions and paywalls. To proceed, we used Sincere to generate synthetic patient and prescription FHIR data and developed Python scripts to simulate pharmacy records not available through Sincere. We addressed data referencing challenges when integrating both datasets into our database. For deployment, we evaluated Heroku, Vercel, Avon, Render, and Netlify. In the end, we hosted our Spring Boot backend and Angular TypeScript frontend on Render and used Avon to host our MySQL database, achieving a cost-effective, scalable, and easy to manage production environment.
I'm Amrit, and I'm going to be discussing the gaps in our research and implementation. The first issue that we ran into with our during research and implementation is that we discovered that the API that we wanted to use to show other pricing data was not taking new customers. So the GoodRx API, which is what we were hoping to show drug pricing alternatives, was not. We were not able to access that API to use in our implementation. So we were able to mock up this data ourselves, but it was not real world data. The second issue was that the free tier of our deployed database had a storage cap on the data, so we were only able to test small samples of data. And finally, there's no publicly accessible API for coverage eligibility, so our implementation randomizes the base cost and the payer coverage for the medications when we make our queries. But these were three issues that we ran into while we were planning this project and then trying to implement it that it prevented us from creating a more real world web app.
Hi, I'm Stephanie, and I will jump into the demo portion of this presentation. But first, I want to talk about the tech stack that we have. Our front end is built on Angular. Our backend is built with Spring Boot. Our database is a MySQL database. And for the deployment, the front end and backend are deployed to Render, and the database, MySQL database, is deployed to Avian. All right. So before going into details, I want to just do a high-level overview of the application as it flows. The intended user of the app is a provider. So here on this landing page, this is from the provider's view. On the landing page, the provider sees a list of all their patients, and each patient card can be clicked into for further details. A new page opens, and the provider can view active prescriptions, prescribe new medicine based on condition, and reach out to a patient if necessary. So to begin with the demonstration, the provider starts at the landing page and can see the patients. The main functionality of this application is in the individual patient cards. So let's click into the patient card. Moving forward into the demonstration, I'll go over the following features of our app. So first is the patient overview. The second is choosing and prescribing medication for a condition. And the third is medication fill status tracking. And the fourth is the chat feature that we have. So starting with the first feature, a provider can see information of the patient. So here's the patient overview. The provider can choose to show more details on the patient. The purpose of this toggle is to just simplify the UI to not overwhelm the provider with maybe unnecessary information. The next feature, the second feature, is choosing and prescribing medication for a condition. So the provider can use the condition selection box here and select a condition. So here we have diabetes and hypertension. We just for our prototype purposes, it's quite a small list, but this would be conditions from the SNOMED dictionary. These are conditions from SNOMED. In the back end, it stores the SNOMED code. And in future implementations, we would have many more to choose from. So when the provider selects a condition, a list of medications is retrieved from the backend for that medication using RxNorm medication and standards. So let's say I choose diabetes. And so already the backend has made a call for the list of medication. And on that call as well, a second call is made for the coverage eligibility of a patient. So this would be the equivalent of a coverage eligibility request FHIR resource. At the moment, as mentioned previously in the document, this is randomly generated to mock the total cost and base cost, as there are no publicly available payer APIs. And once the condition is selected, the provider can click Select Medication. So here are the data returned, which is the medications and payer coverage. What we can see is a list of all the medication that is covered by the payer and the cost associated with that. So the high-level information shows the medication and the cost per unit. The provider can also go a little bit further to show coverage details. So we have the total cost and we have the payer cost, and the dispenses is 1. Total cost per unit is calculated based on these 3 values. The provider has the option to scroll through this list. We can see a large amount. These are all RX norm standards. And here the provider can just compare and contrast different options. If we scroll down, the provider can also see if there's any alternative coverage that doesn't come from the payer itself. In this case, there is none. I think for the hypertension, however, we can see here an alternative coverage for this patient is available, which significantly reduces the price for the patient per tablet. Let's go ahead and prescribe a medication. We can do diabetes. And let's just go ahead with this first one and press select. So what happens here now in the UI is that the medication label and value is updated to reflect that medication. The cost per units is just here to kind of give an idea on the cost. So this text field is enabled once that select medication occurs, and the provider can put in the number of units they would like. So let's put in 500. When the provider clicks prescribe, this will send a medication request to the backend, as well as a fill status entity, which will represent the medication dispensed information. The fill status entity will be set to dispenses equals 0. So we go ahead and prescribe. Now, once we refresh the page here, we'll be able to see that in the next feature. Which is the third feature is the prescription and fulfillment history. And there are two portions of the segment, the active prescription and the past prescription. This would resemble the real status of the medication request itself, specifically the status. Any prescription with an active status will be seen in the active prescription portion. Any prescription that is not active, for example, ended, on hold, stopped, etc., would be in the past medication segment. So we prescribe 500 units of the diabetes medication, and we see it here. And the toggle buttons just help the avoid clutter in the UI. The provider can also see the past prescription details. So I'm going to go ahead and toggle this back so that we have a clean UI. The final feature is the message and chat feature. So this feature is a tool that allows the provider to see on quick glance the status of dispenses on active prescription. So again, our test patient here has 13 unfilled prescriptions. The provider can choose to contact the patient with the contact patient button, and this opens a message box to send a pre-written message to the patient. This message gives an alert to the patient for which medications have not been fulfilled and inquires how the provider can help that patient. So on send, it will send to the client portion of the app, which is set to be built in future implementations. And I want to go to the next slide and talk about future work. So I left the demonstration on talking about a future implementation, maybe with the client. One of these future implementations would be having different users with different profiles be able to use this application. So at the moment, we only have a provider profile. However, the next step would be to have the patient access profile. They would be able to see their medication, but they would also be able to receive the messages that the provider sends them, as well as send the messages back to them. So that's one future work item that we have. More under technical, refactoring for scalability. So at the moment, some of our entities are made kind of with this idea that we're working with limited data, specifically the patient and medication resources. We use Centea data to generate them, and then just because of the size of our application, we actually we join them into a table. However, in future iterations, what we would do is adjust those tables to decouple them and to have a one-to-many relationship with the patient and medication. Just adjusting certain variables in the UI, probably you've noticed that on the prescription fulfillment status section, we can only see the medication code. Our next implementations would mean that we would add a little bit more detail, more than just the medication code. Additionally, user authentication, so login screen, and allowing even more providers. Kind of on the business side, I would say, as we are an application for medication payments, at the moment, there is no free or publicly available API for getting coverage eligibility response from payers. I mentioned that we had to mock that data up. But this would be the next step into kind of exploring how to bridge that gap, see if there are any options to make it more representative of communicating with an actual payer. Additionally, medical information. To get information for what medication treats what condition. As I mentioned, the condition drop-down box, we only have the option of diabetes and an additional condition. This is partly due because it was quite difficult to find lists of medication as someone with no medical knowledge, a list of the RX meds that can treat those conditions. And so the next iterations, basically, we would either, source someone who knows better and can map a connection between them, or maybe find another resource that already has that done. For research, we would definitely need to conduct more need finding with our target users. We would want to conduct surveys and prototype testing and kind of get an understanding of if we're on the right track with our application. And that is it for our future work. And I want to say thank you very much for your time and attention on the presentation.